Hello, everyone, and welcome to today's webinar, How to Use Compuware Topaz to Build Integration Digital Systems 10 Times Faster. As part of webinar series OpenLegacy is hosting on BrightTalk. My name is Marty Bacall from OpenLegacy. I'll be the moderator of a panel discussion between Rick Slade, Chief Solution Architect at Compuware, and Zev Avidan, Chief Product Officer at OpenLegacy. So first, this is just going to be straight in questions, but feel free to add some questions on the question mark icon. You can add your own questions. We love to handle your questions during the webinar. Rick, we'll start with you. Why does the integration between OpenLegacy and Compuware make sense for users, and what are the benefits?
Well, thank you, Marty, and thanks for everybody who's joining us live. Yeah, there are just so many benefits to being able to leverage OpenLegacy's API technology in combination with our delivery capabilities. There's so much work going on in today's world, especially in the traditional brick and mortar organizations where they are trying to digitize a lot of the software and how they operate. And so when I talk to folks on a regular basis, there's really two types of modernization that's going on in the world today. There's the modernization of the software delivery environment, which we provide solutions for. And then there's also the modernization of the existing application stack. And why this combination or why this integration is so important is that I think that what Compuware does is give the developer the ability to leverage OpenLegacy's technology faster, but then to build and test and leverage all of the software delivery capabilities that are part of modern software delivery. So as organizations are starting to modernize their application stack, and they're starting to segregate or componentize, is the term I like to use. The ability to generate, build APIs to leverage or to access existing working code is a huge benefit to organizations. So instead of taking services that they're leveraging today and re-engineering those onto another platform, they can leverage working code very quickly using the OpenLegacy technology and solutions, and then they can deploy or deliver that code to a production state using Compuware tools. It's a great combination of modernization at the application level and at the application or software delivery level.
Yeah, no, absolutely. I mean, we made a great point about the process being important as much as the architecture. The architecture, I mean, there are many reference architectures on microservices, and people are really moving there in great numbers. But there's this kind of disconnect where all of a sudden say, well, the legacy system will integrate to that the same way we've been doing it for the last 20, 25 years. And that doesn't really work. I mean, that doesn't get you to the speed that you want to get it. That doesn't really make you digital, because being digital is about the entire end-to-end process. And there's no business process that does not cross at least a couple of platforms, right? So you have to have an end-to-end process, not just the technology, not just I have some integration, but really a way to do that in ways that are like a modern software factory. You might call it the API factory, but that's really what is needed. And so that's a great point by Rick in terms of the decoupling, or not decoupling, but making the end-to-end process as much as your kind of target environment as the architecture itself.
Yeah, exactly. I think it's so important that if your organization is looking to digitize or to automate a lot of their existing services, I mean, there are two ways, I think, from a software delivery standpoint, from a software standpoint, to go fast. It's to improve the architecture of the existing stack, and it's to improve the means by which you deliver that stack to a production state. These two solutions give you that.
Thank you very much. And so now the next question, we'll start with Zev. How does the integration actually work?
So the OpenLegacy API integration platform is kind of a new take on an old subject. we've all been around. We know that enterprise integration has kind of really been using the same concepts, middlewares and service-oriented architectures, ESBs, which were great for the day. I mean, they solved a really big problem around data governance, or integration governance, around scalability, around being robust. All of these were big issues back in the day, but now they're being solved at the infrastructure level, right? And so the real big problems of today is really kind of the process. I mean, how do I get to speed, the velocity of deployment? And how do I integrate into, for example, my mainframe in a way that's seamless? So I don't have, separate pipelines for my mainframe and a separate pipeline for my every other type of development. So really, OpenLegacy is about digital-driven integration. It's a new take on integration. Really, it's talking about how do I make those mainframe assets available as digital assets very, very quickly and directly. So it's a new way of doing things. It works very well with the concept of the Topaz framework, because basically what it allows you to do is to have your mainframe developers really focusing on what they know how to do best, not confusing them with things that are not relevant to what they need to do, but actually aligning everybody, the digital side of the house and the mainframe side of the house, in that kind of unified pipeline. So it's both on the architectural level, it's delayering things, it making things very simple. Those are microservices talking directly with the mainframe. But also, very importantly, in terms of the process, you can automate a lot of it, and automation is key. And I think we probably have something to say about the automation part of it, but that's really what we see as kind of a key concept in terms of being fast.
Yeah, I think that integration is so critical. When I talk to clients, I talk about this assimilation or conversion or consolidation of a software development environment, regardless of where your target is. And I think that becomes critically important, not only from a technology standpoint with regards to managing the cost of that environment, but also from a resource standpoint, the ability to start to leverage resources who have skills maybe unique or specific to certain platforms. We can start to see a merger if we can provide those people with a common platform or common look and feel with regard to how they do their work. The thing about automation that I think is so important is automation gives us the ability to start to leverage resources across multiple platforms, because we can take the nuances of those platforms and automate that work so that the developer can focus on logic changes or feature capabilities within the software, and then the build, test, and deployment components can be automated in an integrated environment to minimize the knowledge required by developers regarding specific platforms. So that integration into a common development ecosystem, I think, is very important.
Thank you very much. So, Rick, how does the process ease the burden from mainframe development teams?
Well, if you think about how a lot of this work is being done today, there's a tremendous amount of re-engineering that's occurring in a lot of these systems. So to expose those services with what OpenLegacy is doing and the ability to very easily take that code and to expose it through APIs eases the burden of that traditional mainframe developer who is having to learn how to do that type of engineering work, along with identifying, where it can occur within those legacy systems. With tools like program analysis from Compuware, the ability to do better and faster searches to identify where you've got opportunity to expose code, working code, as an API, makes that process so much easier. There's not a tremendous amount of learning that has to occur by the mainframe developer to leverage that technology. And then with the Compuware software delivery capabilities, we have the ability to not only make those changes to generate those APIs, but then to test and deploy those components to their respective targets.
Yeah, I mean that's exactly right. I mean, basically, if you're talking about these kind of efforts, you have two main aspects to them. There's one which is identifying what assets do you have on your mainframe, for example. How you can rebuild them into a new business service or really expose the same business service, enriching them. And there's the challenge of what kind of infrastructure, or what do you need to do in order to actually create the integration. And so here you see kind of a complete solution. Why? Because the Topaz framework, basically what it allows you to do is to discover, work with, identify, make changes if needed to the underlying assets. But then when you need to expose them in the integration side, then your mainframe developers, they don't deal now with things like, security tokens and analytics frameworks and all kinds of things that really belong on the digital side. All of that is automated for them. So they just basically expose a copybook, and everything is done from there on the digital side. So really kind of it's an end-to-end solution where you can really have your most, usually these are your most scarce and valuable resources, the mainframe people. You can really have them focus on the thing that at hand, on the functionality, and basically automate everything that's not kind of something that needs to be their immediate concern. And really, when you think about it, that's where a lot of time gets lost. The mainframe folks, they can work pretty fast. I mean, I've been doing mainframe. I've been a system programmer for 20-something years. Things can happen pretty fast on the mainframe. I mean, it has this bad reputation for being a slow platform, but actually it's a pretty fast if you're doing it right. It's percolating the change that usually takes a lot of time, because that's where two types of technologies, mindsets, cultures clash. And if you can automate that part, that will yield the best gains in terms of productivity.
So if I get in trouble with my own team sometimes, I deploy the term mainframe modernization. And I talk to customers, people talk about mainframe modernization. It's used throughout the industry, and I understand why. But it drives me crazy, because as a platform, it's the most modern, most incredible platform there is with regarding transaction processing. There's nothing more modern than today's mainframe as it operates. What has to be modernized are the processes by which we deliver software and the methods by which we change software to accommodate the needs of faster time to market. And so I think that's what's so great about OpenLegacy and the combination of Compuware's solutions, is that we provide that ability to do that work much faster. So we're modernizing the process of re-engineering. We're modernizing the process of software delivery and not the platform.
Okay, so Zev, does this support both inbound and outbound traffic? Meaning not only leveraging existing legacy logic as a service, responding to requests, but also the service to leverage other services that may be off platform?
Yeah, absolutely. So on the OpenLegacy platform side, there's the two flows exist. So you can expose those programs, transactions, tables, whatever is the asset on the backend side. You can expose them as APIs, but also you can on the mainframe consume APIs, and that is done through a facility called an API caller. And an API caller is basically a code generation facility that creates both kind of a proxy object and all the things that you need on the mainframe side. So it creates the COBOL copybooks and the COBOL business logic, for example, that will allow a COBOL developer, for example, to call an API without ever knowing that they're calling an API. They're just calling a program, another COBOL program, and for them, it's just a normal way of work. But behind the scenes, it actually does the work of calling the API. So it does work both inbound and outbound.
Rick, anything to add there? Or
well, I just think that's important. I mean, if you think about the mainframe, there are a lot of services out there that are working, that are good, and there will be a desire to enhance those systems through services that are provided off mainframe. So using this API caller technology that he's talking about, you have that opportunity now to expose existing mainframe applications that may be leveraging web front end, but the ability to initiate that API request from the mainframe. That's incredible technology. And again, it speaks to the power of that mainframe. I think you're going to see a lot of centralization of services to that platform because of its availability and reliability and scalability, and the ability to initiate external requests is an important feature. So being able to support inbound and outbound, I think it's a great capability from the OpenLegacy solution.
Great. So Rick, we covered this a little bit, but how does this type of integration speed the mainframe DevOps process?
Well, a lot of that speed is in instead of re-engineering a lot of code, I can simply use automated analysis tools that we provide to identify potential code that can be exposed, and then leverage the OpenLegacy solution to build an API that can initiate requests to that. So the development work is going to be minimized significantly, I think, for the mainframe developer that may have to make modifications to that code. With the OpenLegacy solution, that is minimized significantly. The other thing, that working from a common development ecosystem, Eclipse in this particular case, you have the ability to work from one environment, and you're not moving in and out of the mainframe or in and out of other development ecosystems. You're within one ecosystem, leveraging the ability to support continuous integration, continuous delivery, continuous testing, and even continuous deployment of code, potentially with the Compuware software delivery solutions.
Yeah, I mean, one of the nice things here is that the artifacts that are being auto-generated are completely standard. So, for example, standard Java artifacts, there's nothing special about them. They're just Java. That means that it opens up the entire Java ecosystem of DevOps and automation for you to use. You don't have any special kind of testing module. These are just JUnit testing modules. You can introduce whatever framework you want to introduce because it's all available. And the really nice part is when you get to it, I mean, basically what you can do, for example, is you have the Java side, which is the service, the microservice and the API, and you have the COBOL side, which is the actual business logic behind the scenes, and you can basically debug them together on the same platform using the same tool, and it's all in Eclipse-based kind of a tool. You can debug the entire end-to-end process. That's a very powerful thing, because if you think about it, usually that's not the case. Usually that you have the open systems people saying, "Well, it's a mainframe problem," and the mainframe people say, "No, it's that problem." Here you can see exactly where the problem is, and you can debug it the same way. You can test it in the same way. So it really kind of aligns the entire process together, and that's a really powerful thing in terms of being able to move faster.
Great. So Zev, why are Microsoft-based APIs an important part of the process?
So basically, when you talk about, microservices has not been, it's not a completely 100% new approach, but it has been enabled by newer technologies like containerization and stuff like that. The reason why that's so important, and I would say, it's not like microservices are the solution for every problem, but in the spaces that we're talking about, in the domains we're talking about, where there's a lot of complexity, they do provide a lot of value. And that value is specifically around being able to decouple everything, make everything more modular, and really kind of being able to deal with the specifics. Also being very, deploying things very quickly. Now, I'll be the first to say a microservice is a simple thing. A microservice architecture is not a simple thing. It's more complex. That's why automation is so important. But if you take both the technology, containerization, microservices, frameworks like Spring Boot, and the methodologies together, that's where you get the impact. Just one or the other will not get you the impact that you need. If you put them together, that's where you get a lot of the impact. And really, large bank or financial institution, think about a decade ago or more than that, they used to deploy 2 times a year, 4 times a year, and that was a major event. Deployment to production, everything shut down, and there's a freeze and code freeze and stuff like that. A Facebook would deploy to production 10,000 times a day easily. Now, I'm not saying that every bank should be as fast as an emerging, internet company, but more and more they're skewed towards that. So if you really want to be able to deploy, many times a day into production, you have to go the microservices route. There's no way of doing it in a monolithic environment.
Okay, thank you. Rick, do you have any comment on that?
No, I think Zev's covered all the things that I think I could cover. So no, I'm good with that. Good response.
Okay, Rick, please give us an example of customers who could benefit from this integration.
We've got several customers. Just about all customers that we talk to with regard to modernizing their software delivery environment, which is the solution we provide, are also modernizing their existing stacks. And so there's a significant amount of work going on in the industry to build or to leverage application architectures that allow you to make changes faster. being able to respond to changing market conditions or changing compliance requirements can be challenging for organizations. And so, as Zev and I both have said, it's not just modernizing how you deliver software or just modernizing the stack itself. It's a combination of both that are going to maximize your abilities as an organization to deliver code to a production state as fast as possible. And so, if you're a large banking financial institution, or your traditional brick and mortar that's leveraging a lot of back-end services that could be exposed or leveraged through a mobile device or another web device or some other device that, an IoT or Internet of Things device, there are lots of good working code that can be leveraged without going through all the processes of retesting, rebuilding, re-engineering that code. So if you're an organization that has code that's being leveraged to support non-digital business transactions or business services, and you're looking to expose those services or to automate or to digitally transform those services, this becomes a very viable solution. And again, very few customers that I talk to are not looking to not only modernize their software delivery environment, but also to modernize their application architecture so that they can maximize the speed of change.
Yeah, no, I think everybody's modernizing at this point. I mean, everybody has a digital transformation, but I will talk about some specific use cases that we've encountered, which I think are representative. So first will be, regulation and compliance is definitely a driver in this market, both in terms of privacy laws and stuff like that, you can't afford at this point to leave data sources untouched. If you have to, you have to tell the customer what you know about them, or even, there's the right to be forgotten. You have to touch even the deepest, kind of most arcane data sources. If it's complex file structures or databases or older systems, you have to be able to access them in a fairly quick way. But also in terms of the arms race, where because of regulation, things open up. So there's the PSD2 in Europe. There are other types of regulation in other places in the world. But really it becomes kind of an arms race, because if it's easy, for example, I'll give you an example, a bank that's a customer of ours, and their initial challenge was around a new piece of regulation that made it easier for customers to move their accounts for one bank to the other. So it basically necessitated all the banks to provide that as a digital service. And now that started an arms race, because if everybody can move their accounts very quickly, why you don't want to be the one that they're moving their accounts from. You want to be the one that they're moving their accounts to. So that becomes kind of an arms race in terms of who can get the best digital experience. And really, that's all about moving fast. You want to add more digital channels, incorporate more kind of fintech partners. So that is really about how fast can you integrate with those. There are other aspects, of course, commercial aspects and stuff like that. But on a technical level, usually the technology is the stopper, the blocker. But if you can deploy a new integration in weeks, and now they can, by the way, that's a game changer. That's kind of a competitive advantage. There are also things about, re-architecturing your environment. So a lot of organizations have come to realize that hybrid is probably going to be an end state for them. So the mainframe is there to stay. Now, what do you do with that kind of revelation? You want to have the mainframe as a first-class citizen. So we talked earlier about kind of having the mainframe both as a consumer and a producer of an API. Just to give you an example, one customer, what they've done is they moved a big system on their mainframe to the cloud. But now the mainframe is still there. It needs to connect with that system because it still needs things from that system. No problem. It can be a consumer of the API of that new system. It's not a huge change for them, and they've implemented that. And now the mainframe, keeps the core business running, but that specific system, which is about customer onboarding, now can be on the cloud. And it makes sense to have customer onboarding on the cloud. It's closer to the customer. So you have flexibility in terms of where you want to deploy what you want to deploy where. So these are just several use cases. Of course, there are many more, and each organization is different, but there are some emerging patterns, I would say, in this market.
Okay, so does OpenLegacy run natively on ZOS in its own address space?
So maybe that would be a good time to talk a little bit about what actually is does it look like. So no, the answer is no. I mean, those microservices, those Java-based microservices, they can run on the ZOS, on the USS side, but they don't have to. So almost for every type of data source or transaction server on the mainframe, you don't need to really install anything on the mainframe. You don't need to change anything on the mainframe. It basically all of the work is done on the service side. It connects with the lowest level protocol, so an IMS Connect or something like that. We do have a specific solution for kicks because we know that there are a lot of solutions to accessing kicks, but nobody likes them. So we have a different solution for kicks, which is very, very small footprint, very easy to install, very easy to set up, very easy to maintain. But that's an option. You don't have to use it, although most of our customers do prefer it. But no, you don't need to make a lot of changes on the mainframe, which is, usually that's great news for people.
Thank you. And on that, we still support the CTG connector because I know that one's popular as well. But we have our own, so that's a great thing to bring up that we have both. Okay, Rick, how can we start to work with both OpenLegacy and Compuware?
I mean, I assume from a sales standpoint is what you're talking about, but I mean, from a sales, just getting with either sales organization. Now, from a developer's perspective, there are Eclipse plugins. Both run under Eclipse. They're very easy to use. If you've got familiarity with Eclipse and that environment, then this is going to be second nature to you. And so, very easy to get started. Installing those plugins, installing whatever mainframe components are needed. And as Ed just said, there's not a lot of work there. And he can talk more about that than I can, but getting started is easy. It's a matter of installing the plugins and leveraging, a development ecosystem that you're very comfortable with typically.
Yeah, I mean, to continue on your point, getting started is pretty easy. I mean, you can get up and running and start generating services pretty quickly. So, for example, we run POCs. Usually, they are between 1 to 3 days. The 3 days are the ones that are very complex, but that's kind of you're building up from there. And the reason for that is you start by, okay, so how fast can I create services? Oh, pretty fast. That's great. But now I want to automate more and more of it. I want to get to complete what we call an API factory, where it's completely automated from ideation all the way to production. So that, it adds up. Eventually, you can set up an entire API factory in about 30 to 90 days. It's not a huge effort or investment. It really depends on the maturity of the organization. If you haven't chosen, a cloud vendor and you want to deploy to the cloud, that you need to add that part of choosing a cloud vendor. But in terms of the technical work, it's not a huge effort. It's not a huge lift, and you can get some pretty substantial result in pretty short amount of time. I can give you an example where we were able to get, from real engagement, from saying hello to production in a little over 2 months. This is possible. So it really, I would say, the appetite and the temperament of the customer usually set up the pace, but the technology and the capabilities support, how fast you want to go. That's really the question.
Okay, and we'll probably have one more question and then to a wrap up. But another question: is it equally easy or difficult to call IMS service or DB2 or an API? I'll throw in vSAM, which they didn't mention here. In other words, what will be the hardest parts to open up? I'll go to Zev.
Yeah, so I didn't go too deep into how the technology works, but basically there are those integration components that are automatically generated. Once they're automatically generated, and they are automatically generated, so there's no intervention there. They can be in the CLI or kind of like doing mass batch of those objects. And this can be transactions, programs, store procedures, tables, whatever you want them to be. Once they're created, then basically they look the same. So integrating with a DB2 or an IMS or a Kix or whatever is exactly the same. These are just Java POJOs, plain old Java objects. So that kind of standardizes the integration. That means that you use the same integration stack for all of them. And really the hard part, the complex part, which is understanding and parsing the protocols and the low-level kind of access, that is done automatically for you. So it's kind of being brought to a canonical representation in terms of Java data types and naming conventions. From there, it's used inside microservices, or it can be functions, many different technologies, and that's a big difference than from what other solution might have, because a lot of other solutions are coming from a different approach, which is how can we build APIs on the mainframe? We're not saying that. We're saying how can we make mainframe assets available to those APIs as soon as possible in a digital way. That's a completely different way of thinking about things, and that it seems like a nuance, but it translates into a completely and dramatically different development experience.
Thank you very much. And I think I mentioned vSAN because that's one that's hard to get into. So we actually make that look the exact same as all the other ones you mentioned. And I think that's a critical thing. I'd like to thank both of our presenters here today. I think this was a very interesting discussion. For more thoughts on this, you can attend our other webinars in our series of Bright Talk, or you can go to the Compuware website or the OpenLegacy website for more details. There is a solution with Compuware where we have different data sheets and things like that available on the OpenLegacy website under our Compuware under the product area. So a number of different areas, and thank you to both of you for talking with everyone.
Thank you, Marty. Thank you, Zev.
Thank you.
Enjoyed it.
Thanks, everybody, for listening. Thank you.